Huh? Engage? That makes sense. Checking it out. Hey, y'all. Over there eating your pizza. Get in here. Join us for this live stream edition of Chadev. All right, if I could have my speakers sit up front, I want you up front. That's you. That's you, Alex. Yeah, the order in which you sit is going to be the order in which you speak. I'm going to let you guys hash that out. I'm going to run a timer, and there is going to be a strict 5-minute limit. Very strict. The crowd not only has permission, but is encouraged to begin heckling. Of the lightning talk? Was it? Wow. No, we're doing 5. I said 5. A lot of people still hanging out. Somebody go yell at those people in the kitchen and tell them to get their asses in here. Hey guys, ladies, gentlemen, let's go in here. Take it in here. Are we live streaming, Kyle? We're live streaming. We're live streaming, guys. Come on in here. Say something.
No.
Tell us how much you love Chadev. Tell us right now.
Oh my gosh, I love Chadev so much. I did nothing on my computer until Chadev today.
Guys, we're starting the lightning talks. We're starting the lightning talks. I know, but they can hear me, and it entertains me that they can hear me. I know. All right, here we go. So here's how this is going to go. You have 5 minutes. I will be timing you. The crowd will begin heckling if you go over. Speakers, please come sit up front here. That way we can make sure this goes as seamless as possible. Also, I need to get an actual count of how many speakers we have and who's showing up. So once I leave this, you guys are going to be running this thing. We're going to start on the end here and work our way down. So the order in which you sit is the order in which you will speak. Come up, give a quick introduction, who you are, where you're from, your name. And then get right into it. Let's talk about welcome to Chadev. If you didn't know, that's where you're at. It's a weekly series of lunches. Welcome. Our partners, let's give a shout out to Open Table and the rest of them. They make sure that we have this wonderful, delightful pizza every single week. You can check these slides out right there. You can tweet at a sponsor. UTC, UT Chattanooga. Give them a shout out if you have a minute. Have your phone with you. Tell them thanks. Thanks, UTC, for that pizza. We love you. We're live streaming. You are on video. If you're not supposed to be here, you might be worried. You might want to worry a little bit because you'll be on camera. There's a camera right there. It's pointed at the audience, and we're probably going to cut to you. So you can get us on social media. You know that stuff. These are all the meetups that we have. You can access this list later. Chadev survey. Go take this. It's important. We're going to put together all this data, and we're going to reveal unto you the secrets of Chattanooga tech industry life. Get us on Slack. You can get involved here. And that's all I'm going to say. I'm going to pass it off for a quick announcement.
Thank you. And the announcement has to do with that slide on the meetups. So the next week is a couple coming up. Justin's got his Python one on Monday night, right? Yep, going to be here at 6. Okay, very good. Then on Tuesday night, we have the DevOps one. We're going to be covering the M and CAMs, so the metrics, and we're going to be doing monitoring and probably focusing on Nagios. So that's here at 6 as well. Hope you can show up, and there's an official meetup for that if you need to go sign up and find out more stuff. Thanks.
Hey, I'm Jeff, and I work for Variable Incorporated. I'm trying to mirror or make two different displays here. Arrangement. Ah, yes. There we go. Yeah, I'm not sure if I belong here. Let's see. Hey. There we go. There we go. Okay, so my name's Jeff. I work at Variable Incorporated right now as sort of a data scientist / machine learning engineer. And I'm going to talk about machine learning. At one of these lunches, I told somebody that I did machine learning, and they asked this exact question: what is machine learning, and why should I care? So I thought maybe that other people would like to know the same thing, and it's pretty quick and easy to talk about. So basically, machine learning is, I would describe it as algorithms or a set of algorithms that allow the computer to learn tasks rather than explicitly programming it to perform a task. So typically this means that if we have data to describe some complicated phenomenon, we can feed it to an algorithm that will then learn the behavior of that phenomenon, which is pretty cool, I think. This is a good thing because a lot of times the math that actually describes this stuff is really, really hard. And if you know a little bit about machine learning, it's sort of like using clever, simple math tricks to model really fancy math that might be pretty hard to even invent or come up with. So sounds neat, but why should you care? And how could it help you? So first I'll start by saying computer models that describe the real world are extremely valuable in all senses of the word, I think. So monetarily, in terms of research and knowledge that we can gain, they're valuable in that way as well. If we can write miniature simulations of what is occurring in the world, then we can use that to our advantage. So that's sort of what I think is a big deal about this. And so the models that I'm talking about, these models, they're used for research, product development, and to guide decision making in fields like business. If we can model the stock market, we can make more money. If we can model consumer behavior, we can know which product to produce and then make more money. That's the whole idea of business. If we can model the weather, and like in science, meteorology, if we can model physics, we can have things like new clean energy sources, things like that. And if we can model biology, chemistry, that sort of thing, we can create drugs faster, which some might argue is bad. Some might say it's good. I don't know. But you can do that. And then, so speaking of that, there's one thing I wanted to mention. There's people that actually are making robots right now that will execute experiments to design drugs automatically based on machine learning. And so they work 24 hours a day. They don't get depressed if they fail over and over again. They just use what they learn, and they're developing new drugs. And so in engineering, this is where I came from originally. Then artificial intelligence, like all your user interfaces and things that you want to help you in an intelligent way, a lot of that, those models can be valuable for speech recognition, image recognition, natural language processing, etc. So don't you have to be an expert in those fields, one of those, to make a model in that field? And the answer is really not if you know a lot about machine learning. And so, of course, it's going to help to be an expert, but what I mean is that, remember I said machine learning can be described as algorithms that allow the computer to learn tasks rather than explicitly programming it to perform the tasks. Typically, these learn through data, and the data is abundant, and there's not a lot of experts that know how to process that data with all their expert field knowledge. So if you can use some algorithms and use a little bit of your intelligence and gain a little bit of knowledge about the field, you can use machine learning to sort of build models that can be valuable to your company. And companies are looking for experts in machine learning. There's not many of them, and they pay them a lot. There's not many machine learning experts. There's a lot of companies looking for them. So in summary, what I already said 100 times there about what the definition is, and you should care because it's solving really cool problems. It's applicable in almost any domain where data is present, and those domains are growing every day, and then it can make you lots of money if you get a job doing it. And this sounds cool. What's next? I have mixed feeling about Quora, but that's a decent post there. And if you just Google like machine learning blogs or something, that'll come up. And then the time it would take you to learn the newest hipster web tool, you could learn a machine learning framework. So most of you have probably mastered web development or are pretty comfortable with it, so why not expand your skill set? And that's sort of what I'm getting at there. And even if you don't become an expert, you'll have, when you learn that, you'll have the tools you need to become one, and you can just keep using them in your projects, and eventually, you could be an expert. And so if you want help, you can contact me. I may not seem like a super friendly guy, don't usually talk to everybody all the time, but I'm mostly friendly. So you can contact me through the slides, or if you find them, or Slack or whatever. But yeah, pretty much it. I think it's Jeff_McGee or J McGee. So, yep. Yeah, one of those.
There we go.
Cool. Yeah. Oh, you've already got a timer. Awesome. All right. I don't like doing. Well, I mean, look, I could use yours too. It doesn't matter. Okay, I'll use yours. I burned 10 seconds. Shut up, Keithley. Can we heckle now? Yes, you can heckle now. I don't do slides. I like to read code, so I have code and no slides. So, how many of you have played with React or Node, JavaScript, Node, played with? Okay, cool. How about just like Node in general? Okay, cool. So React is like, I don't know, umpteenth JavaScript library for front-end stuff that's come out over the course of the past 5 years and whatnot. And it's cool and it's hip and it's awesome and it's now, and you can write web stuff in it, and now you can write native stuff in it too. So React Native is really neat because you can tie it into like iOS and Android development, and it doesn't just have to be web stuff. So in this example, yes, it just looks like regular Node code, looks like React, and it has some event emitters and set timeouts, and it looks like you're running Node on iOS, and technically you are. So if you boot up npm start, you're serving all the JavaScript that's going to be loaded by your app. I'm going to run this API. So we go over here, and we run this. That's really big. It's building, and so it's going to build all of this stuff on the fly, and then it's going to load up. This is pretty much a WebKit view that calls back into a native bridge. So you can specify all this stuff in here, and this isn't a web component. Like, it is a web component, but it's native. This Uberbot tag up at the top that's a navigation bar, that's crossing from the bridge into Objective-C and calling native code. So we could change this right here, devlaunch. And that automatically recompiles everything, and updates live, calls through the bridge, and changes everything as you're typing. So something you might want to do is call native code already. Let's say you want to break out your native app into the other pieces. You don't want to just start off with a whole app being React Native. And you have some code that you have in Objective-C or it's in Swift or whatnot. You want to use that code you've already written because it's faster, because it's not this bridge. So I have this Swift class that I've written, and all you have to do is set up a bridging header that calls into Objective-C bindings for React Native, and then you can pass stuff back and forth. So here I have this WebSocket, this class that implements the WebSocket delegate, and it sets it VoIP so it can run in the background. But if you come down here, I have all these delegate methods that I've implemented, and all they do is they just call this RCT bridge for React Native and send an event back. So if you come over here, this connected event, this disconnected event, message event, all of that, it all comes back here. You just call this native modules and get the class that you've had in Swift, listen, and you get everything back just like it's regular JavaScript. So here, this is a WebSocket that doesn't die. I can put it back in the background, and that'll reload. I can go home. If you give it a second, there, I got a test notification. I didn't even have to use Apple's push service because I was able to tie right back into an undying WebSocket, which React Native doesn't have a polyfill for right now, which is really nice. I don't know about you guys, but I'd much rather write JavaScript in React than Objective-C and Swift, just personally. I already put a lot of effort into JavaScript, and Angular screwed me over, so React all the way. So yeah, it's really simple. React is pretty nice. You write it all in JavaScript, and it's not just like some skinned version that's like CSS and it looks like it's native. It's actually native and calling through an Objective-C like native system. That's all I really have. Go team. React is awesome.
My name is Brent Spell. I work at OpenTable. I wanted to talk a little bit about a very simple file format called Parquet. So it fits within about a 5-minute presentation because it's a really simple thing. Apache Parquet is a portable column store format. So column stores are actually a really old concept. They date back to the 70s. So instead of storing your data in row form, you store it by column. And the advantage of that is you get, well, actually first what it does is Parquet gives you really efficient nested record storage. So if you have like web logs containing JSON or other application type logs that are JSON oriented, it can take these things and shred them down into basically tabular format and then store them in an efficient columnar manner. It does pluggable encoding, so if you have really sparse data, so values don't change that often in your event stream, they can be compressed really efficiently, and we'll see that in the demo that I'll do in a bit. It contains record metadata. So the nice thing about Parquet is that it's not bound to a particular database. Like many applications can use this format. So traditionally, column stores are bound like within a specific database. So you have a MySQL column store. You have other, SQL Server does a column store. But you can't really get at that data without doing an integration task to pull it out and convert it to CSV or JSON or some other format. That's what's great about Parquet is that it's portable and it works with different analysis platforms. So for an example, like Spark, it's a native format for Spark, Apache Spark, which is useful for doing large-scale data analytics across clusters. It can also be used in Hadoop. It's native to the Hadoop format. One of the things it's really good for is, like I said, flattening complex nested JSON records, and it does this efficiently. So it's not just a matter of taking a path in a JSON document and storing some data along with that. The mechanism that it uses is based on finding levels of your JSON or other nested data structure and figuring out whether they're null or not. And then that information is stored along with the column. So it's a really minimal format. It's also really useful for analyzing text logs. So if you have like CSV data, like you may have web logs that are CSV or TSV or whatever, it's really good for representing those things efficiently. Another great thing that we use it for is for archiving transactional data. So you may snapshot your data like by day or by week, by month, whatever. And it's really good for doing that and partitioning your data set. So if you want to only analyze the last month's data or the last week's data or whatever, it's really good for representing that within Parquet. Because it keeps your files relatively small, so you can download it over S3 and do whatever you want locally, or you can actually run queries in Spark across a file system, which is really nice. so you don't have to do it specifically within a file. It'll cross the file system boundaries. So here's roughly how it's worked. This is an example JSON record for a really dumb application, I would guess, if your fields are just A, B, and C. But if your data is represented as a line-oriented JSON, which is a pretty common log format these days, is you just do a JSON blob and then separate your records by new lines. A traditional row-oriented database, if you were to convert this to a binary format in a traditional sense, your records would all be represented one column after the other, and then it would start the new row, one column after the other. Now, a problem with this is that if you have to do a scan over that data, like a MapReduce type job, you're wading through a lot of columns that you may not need, especially if your data is sparse and you have lots of fields that you don't really care about most of the time. Or if you want to do like the simplest thing, which is just run a histogram over a column. Like, you're wading through so much data to be able to just get the fields that you want. It's really inefficient for that type of operation. Column store is basically to invert that model and transpose your data so that columns are stored contiguously. So you get the advantage of compression because if you have sparse columns, it's a really efficient way to do it. In terms of Parquet, actually the columns are represented in terms of pages. So you get a certain contiguous block of data for a given column. And the min and max values are recorded. So if you have a really intelligent storage engine, it can detect, hey, I don't even need to look at this page because I know the values I'm looking at are outside the boundary of this particular column value. May not be that great to see that image, but it's a high-level organization of the file structure. All the blue things are things that are actually stored, and the gray and white things are just logical entities. So like row groups aren't actually stored, for example, and data is organized into pages for a particular given column. One of the other things that's great about the format that I really like is that if you look on the right side, that's actually the metadata for the file. And the metadata is written at the end of the file, and the reason for that is you can write an entire Parquet file in a single pass. You don't have to construct your page data and then compute some metadata after the fact and either stick it at the beginning of the file or awkwardly concatenate them. It actually just stores everything at the end of the file. So whenever you process a Parquet file, you have to reach basically to the very end of the file, then look back, find the metadata, and then you can process the file and you can stream the rest of the file. So anyway, it's a really interesting format. Here's a quick demo I prepared in Spark for the data. This is an extract of, it's a subset of the reservations that we do at OpenTable for October. Here's a simple line-oriented JSON format. And the demo is actually in Spark, so that is to see. It's probably not very easy. Enhance. Better. So here's my JSON file. This is just a list of the files. You can see it's like 500 megs of JSON blobs. This is a simple line that actually takes that file and converts it into the Parquet format. And it's a Spark job running in the background that'll do the conversion, which might actually take a few seconds. Awesome, so now that's done. Here's our Parquet format. In the case of Spark, it actually breaks Parquet files out into separate files by partitions. But you can see this is roughly 80 megabytes of data. So we process this data, and this is using the Scala format to generate a projection of our original JSON data into data records, essentially. And then finally, we'll run a simple query and produce a chart. So after we've taken all that JSON data and organized it, this query actually runs really quickly, like it's only 2 seconds, and that's processing over 3 million records. So you can see roughly, this is a histogram essentially of reservations by number of days booked in advance. So you can see at OpenTable, almost all of our reservations are booked on the same day, like 2.5 million. But you could take that, we could do the exact same thing, run a filter on it, and we could see all of our non-zero records. So that's only 250,000 for 7 days or less. So really most of our data reservations happen on the same day. But we actually do have a lot of outliers. We have some really interesting reservations that happen years in advance, which is really great. We actually did a simple analysis on this, and it's really nice. Like one of them was a ski resort, so that was a really cool thing. So anyway, the file format's really interesting. I think it has a lot of uses outside of just the data analytics community, especially for like archiving and that sort of thing. And it's really easy to convert from one to the other if you say you want to sort on a particular column versus sorting on other columns. So that's all I have.
gonna try to do something here, which may work.
Live again on the yeah, sweet.
So what I'm going to talk about today. What I'm going to talk about today is basically, how many people have heard of WebGL? Know what that is? It's basically a new framework, newish framework in the web browser to do 3D work. And so basically, it actually like does processing on the graphics card. Most people know this if you've used it at all. Who here has used 3JS? Okay, so a few people have, not that many. So that most people that are doing it with this framework that someone wrote kind of a long time ago that I know works pretty well, but it's not actually, it kind of like will let you do some things really well easily, but it doesn't give you like direct access very easily. And so I did something really cool called Shader School. This is a little tutorial that you can do to learn a little bit about shader programming, which is how you do graphics programming on a 3D card. And so I did that, and I got out of it, and I didn't really know how to do anything else. And so I decided to give a little project for myself where I'd actually try to do like a different sketch, using shaders every day, and learn how to get into the browser and actually do all this stuff directly. And so this is kind of like, I put this up on GitHub, and I just to show some of them. And really, I'm just going to show off a little bit here, but. So this is one of them I did, and this one actually didn't take that long. So what's going on here is you start off with a big grid of flat particles, and then on a graphics card, there's two little programs that you can run. It's called a vertex shader and a fragment shader. And so the vertex shader, what it's doing is it's applying a noise function to make it go up. And then the fragment shader like takes each particle and gives it a different color, and that's why there's color in the background. It's applying a gradient to it. You're getting the nice moire patterns. And then there's another program that kind of determines where the camera is. It's all really cool. It's like all that stuff is done in the shader program itself, and it actually, you get to control it however you want to. It's not a whole lot of math. It's a little bit of math. So this is one I did. I'm not really going to go into code. I can show you what this kind of looks like a little bit. That one was, what was it called? Greater Wave. Yeah, that one. So, yeah, try to. I don't know why it's doing this. Yeah. So anyway, hopefully this is slightly big enough. All right. Better? All right. So basically we have a script here. And this is the fragment shader. That's why it's FS. And so this is just applying a color to it. Basically, it does this mix, and that's creating the gradient. So not a whole lot of math there. And the cool thing with doing GL programming is you actually get like real math. You get like vectors and matrices and things like that. And this is the shader. And this actually is a big noise function that I just cut and paste in there. But it's got... it's not a whole lot of code to make that work either, and it just applies that noise function to the altitude. But let me show you some of the other things. Let's see here. I was playing a little bit with lines a little bit. So I have things like this. It's got some like weird glitches here because of the way I did the lines, which I like. So I actually kind of emphasized that part. Let's see. So this one, you can barely see it, but it's a bit of a, so basically there's some math going on here, and basically you can kind of see a little bit here. This is actually happening all over, but it's very faint. And it's just using some weird like mod math, and it's like iterating through it. So if you've ever heard like chiptunes, it's kind of like doing something like that, only visually, like with the altitudes of the particles. And so this is just something I was playing around with, and things started to break in nice ways, and so I kind of went with it. Okay, so the thing I really wanted to talk to, and that's the reason why I turned the podium around, is because one of the really cool things you can do with 3D programming is you can get the access to the webcam through the browser, and then take the image from the webcam, and then feed it in as a texture to the graphics card, which is just awesome. So basically, hopefully, yeah, this will work. So this is you. So you can wave. So basically, I'm using the luminosity of the image to like push the points out in space, and then just kind of rotating around the image. So so you can kind of see yourself. You can see all the points in space, and so there's a lot of things you can do with this once you have access to that data. And the nice thing, almost everyone has a webcam in their computer. So it's like, you know, you can do cool things with Kinects, but no one has a Kinect. But everyone has a webcam. So let's see, what's another one? So this one hopefully doesn't make people too sick. It's just kind of like, this one's really easy to do. I kind of like it, but not for too long. This is one that actually I had the idea for it, and I kind of implemented it. It only took 2 seconds. I mean, it took like 30 minutes to implement once I realized what I wanted to do, but it's actually one of my favorite ones. Some of the other ones took a really long time. But all that's happening here is there's like a noise function that's like affecting the pixels, basically determining what the aliasing is for the pixelation. And so you're getting this like kind of nice smooth function on top of this very like jagged pixelating function. So anyway, this is one I'm probably happiest with. And see here, that's just some more lines. Playing around with that. Let's see here. Okay, so this one I'm not sure. So this one often is too dark. So this is actually playing around with a little bit of CV, like computer vision, trying to figure out like do some diffing. And so when it works, and it's like, yeah, I don't think it's gonna actually be bright enough. So this actually does motion detection. It'll determine the difference between two frames, and then you can actually like modify it based on that. But wait a second, let me see. If I move in the frame and move out of it, it's not good. Yeah, because the thing is, it has to be tuned just right for the lighting conditions. You can kind of see it on the screen, but it's not really showing up that much. You can see it better on this one, I think. Can everyone wave? Yeah, so you're getting a little bit of that, which is, yeah, it's kind of fun. The other one actually is really nice when it works. And see here, I think that's about it. So this is another one. This is just like getting really, really glitchy. What's actually happening is there's something moving, is like a 3D shape that's kind of moving in the background, but the way it glitches, it kind of makes it like this 2D shape. And so this kind of like what I've been into is like playing with like taking 3D things and converting the 2D, making them look somewhere in between 3D and 2D. So anyway, that's it. I think I'm out of time anyway. And I just want to say that if you guys anyone is into this kind of stuff, and we have an art dev group that kind of tries to work with different technologies like this, making cool things happen. So definitely recommend you come show up for that. Thanks.
Turn around. That's fine. I just need to go one book page. I'm not actually going anywhere. StackOverflow.com. All right. So, who here is not familiar with StackOverflow.com? Great. That's what I was hoping for. I don't need to sell this to you. You guys already know how to use that. My name is John Holland, and I work for ClearSpan Components Incorporated, and I'm the VP of Software Engineering. So what I'm going to talk about is one of the strategies we use with Stack Overflow to help our documentation, to help our communication, and our production. So who here actually has an account, like has actually asked a question or answered a question on Stack Overflow? So that's not everybody in the room. Everybody knows what it is. Everybody's gone there for help. It shows up in Google, but not everybody uses it. So everybody's familiar with there's a question, there's an answer. I wrote my senior thesis at college on Stack Overflow, and it takes an average of 12 minutes to get an answer. And those statistics are ridiculous. Who here usually solves the task they're given in under 12 minutes when your boss gives you something to work on? Nobody raised their hand. And I know that's kind of like tongue-in-cheek, because it's like, well, it takes time to write a good question. And I get to go through a lot of resumes, and almost every resume says, oh, well, I'm good at communication. I'm good with my team. I can explain something. So I'm going to take you through a quick scenario, and you've probably seen it on your team of whatever size you are, unless you're just a lone developer. But you have an assignment. A junior developer has a question. He goes and asks the senior developer who knows about that technology, how long does it take for him to explain his question, bring him over to his desk, show him what's going on? It takes a little bit of time. What if that senior developer's like, no, you know who's great at this? Greg down the hall. He knows exactly about this. So then you bring him there, and you got to describe the question again. So what I have my guys do to avoid that situation is the very first thing I have them do when they run into a problem and they can't solve it in the first 15 minutes, they have to go write a Stack Overflow question. And the purpose, and I've heard the term help vampire, that's not the first goal. The first goal is for them to write it down once and send the link to everybody who needs it. The senior devs usually have really good advice, and why keep it just as the senior devs? That's okay, that's all I'm showing. Why just limit the advice from the senior devs? Why not just have the rest of the world look at it and see what they know? The rest of the world has good ideas. We've all seen open source works pretty well. So that's what we do. That's my requirement for my guys, and the results have been pretty fantastic. And earlier in Slack, about 5 minutes before we came, I had one of my guys write up a question and put it in there. I don't know the address, so you guys can go look it up. It's listed by Scott Holsma. My guess is we have an answer by now. I have my guys, whenever they're left with something to do by the end of the day, before they come in the next day, they post their question. Most of the time, it's answered before they come back. I've been impressed. The number of question answerers versus question posters on Stack Overflow is almost 10 to 1. I don't know what it is about people loving answering questions on there, but fake internet points are like worth so much to some people. So that's most of what I was going to share, is the tactic that we use to get that done. And the very next part, and this is only a small part of a talk I gave to the Python group about a year ago, brings lots of ethical questions. Well, he just sent a link out to the whole team. If this works just like Google in that you have pages, the front page gets more views, back pages get less views. So if the rest of the team clicks upvote, oh great, if there's 7 people on the team and everybody upvotes it, you know, we got 6 votes on it. This looks like a good question, right? It does raise the amount of attention it gets. The number of views, number of votes, it actually dramatically increases for every vote, every view it gets. So are there any ethical questions there about like, oh great, if I just tell all my friends to upvote me, it works great, right? So you guys can think about that a little bit. What does that mean? Is there like, oh, it's okay as long as it's a person clicking it? Why not just have a little bot that manages everybody's account and makes sure that that upvote gets put in there so it gets more attention? What's the answer to that? Is there a limit? Is it okay at this point, but it's not okay at this point? It's a really fun thing to think about, because it's not so cut and dried. It's like, well, what if it was a really good question? It deserved to be upvoted. There's lots of questions. No, it helped. And the biggest point of that is, okay, my senior developer could have helped the junior developer by spending 15 minutes answering his question, or give it more exposure by clicking upvote. As a manager, it's my interest that they get as much done as possible. And that if I have one junior developer taking the time of a senior developer, then both of them are not working on the other task, kind of condensing all of them working on one spot. When the rest of the world, the people I'm not paying, could be solving that problem. So there's plenty of ethical questions there. Is that taking advantage of the rest of the world and the internet? Is that okay? Is that not okay? Maybe I'll come back and give another talk on that part. So in conclusion, those concepts are what we've used for Stack Overflow. And it's the same concepts that we've used for a lot of our open source work. We've open sourced all of our libraries that don't have, not something we're selling. We actually have written a library called the unit class library, because I couldn't come up with something better, and the geometry library. That is our open source code with the same ideas, like, okay, great. It has all of the insights and experience of the people on my team have already given their 2 cents as to what could make this well. Open source works because the rest of the world has good ideas too. So the more eyes you have on your problem, the more likely it'll get fixed. Last thing, we're hiring. So that's my final plug. If that sounds interesting to you, if you have innovative ideas too, we're hiring for front end, back end, and IT and DevOps. Thanks. Oh, my name's John Holland, and I work for ClearSpan Components. If you want to talk to me later, I have cards for you.
I'm going to try and blow through this really quickly. I'm just going to talk about numbering systems, which some of y'all may be very familiar with, but some of it, I found it very interesting. I saw a class on Evented Mind, so I just thought I'd sort of regurgitate that for everyone. But these are all equal. We've got tick marks, base 10, which we use every day, binary, octal, hex, and we'll kind of go through why those are equal. So tick marks are super simple. There's one symbol. You increment the value by using that symbol each time. It can get a little bit more complex. We can add 2 symbols. You can have that hash across there. But position doesn't matter in tick marks, so either way. In our system, position does matter, positional-based numbering system. And the reason why is you actually read the number, or calculate the number from right to left, which is inherent from the Arabic ancestry of our number system. So represents the base of exponential growth, and the symbol in the position represents a multiple of that. So we'll dig into that real quick. So here's 123, which we're all very familiar with that concept, but there's many symbols as there are base. So this is a base 10 calculation, and we're just using powers, and anything to the 0 power is always 1. So we would calculate it as 3 times 1 equals 3, 2 times 10 to the first equals 20, and 1 times 10 to the 2 equals 100, and that's going to be 123. So in binary, which we use in computing, and we'll kind of go into a little bit why, that's a base 2 system. So since there's 2 symbols, 0 and 1, and we would calculate it like that. So that's actually going to equal 5. So why binary? And this is real quick, but it's easier to represent 2 states in a circuit than 10. So if the system has an arbitrary threshold in the voltage, and you can sort of say now it's on and now it's off, and if you want to know more, you can read about Claude Shannon. So binary, you've got 8 slots. See how the exponents increase as we go to the left? So each position of the slot is called a bit, and 8 bits are called a byte. We might normally think kilo equals 1,000, but in computing where things are base 2, kilobyte is 2 to the 10th, which is why sometimes it took me a little while to understand why we got to 1,024 instead of just 1,000. And with megabyte, it's an increment increase as well, so bytes and bits. It takes a lot of time to write these large numbers, so we can increment a little bit faster. If we use octal base 8, same thing, 8, so there's 8 symbols. We all know those. We could calculate it like that. Very simple. So how do we represent the value of 14 in octal? 16. All right, so consider how it relates to binary. What's the largest value that we can do in a set of 3 bits? 111, 7, and an octal? There you go, just 1. So we can represent any 3-slot binary number with a corresponding 1-slot in octal. So we're saving space. So these are equal. And it all checks out. This looks familiar to some people. File permissions. Here's why. You've got 3 types. You've got read-write. It all kind of breaks out. This is probably very familiar to people, but at the root of it, it's just binary calculations. 766, which we all know how to calculate now. So hex, very similar, 16s. As many symbols, obviously it gets a little confusing when you get to 10 because is that a symbol or is it a 1 and a 0? So use the numbers to represent values up to 15 and calculate that number. Consider half a byte, the largest, again, 15, and you guessed it, in hex, only 1. So we can represent any 4-slot binary number with 1 slot in hex. They're all equal. Designers of CSS looks familiar. Now you know why. It's a collection of 3 hex sets, and that's how it calculates. That's it.
All right, it's 12:55, and I guess some of you probably need to get back to work. Is there anybody that said that they wanted to do a talk, and I forgot? That's totally possible. No? All right, so for those of you who need to go back to work, feel free to leave. Chris, you want to come up and swing it? Yeah.
Hi, how's it going? Normally I would get up here and talk about like Elixir, or talk about testing, or React, or D3. I'm not going to talk about any of that. I'm going to talk about this other thing that I care kind of more about. Or Pokemon. I'm talking about keyboards. Yes! So about a little more than a year ago, I was doing independent contracting. I was working a whole bunch. I actually developed really terrible RSI, like to the point where I could barely work. And so I started, I went through kind of a whole ergonomic thing, and I wanted a better keyboard. So in order to get a better keyboard, I actually just built one. And this has sort of been a long process. So this is everything you need to build a keyboard. It's a bunch of diodes, some keycaps, O-rings if you don't want to bother your office mates, and also some clear switches or some others, mechanical switches. And some sort of controller. That's a Teensy, which is kind of a derivative of Arduino. You also need something to put all this junk in, so that'd be a case. I just got this cut out of acrylic on the internet, which turns out you can get acrylic cut on the internet. That's awesome. So yeah, there's more case. This is just a bunch of photos I have. Yeah, it ends up looking like that when you actually pull it all out. And this is called an Atreus. It was built by Technomancy. If you're familiar with Technomancy, he wrote Line, if you're into Clojure. More case stuff. Yeah, okay, so this is dry fitting the keys in there, and that's what the keyboard's gonna look like once it's all done. Keep going. Okay, so the first thing you gotta do is, this is what the acrylic looks like, and you can see what I've done is I've hot glued these switches in here, because obviously the best thing to do is use hot glue to hold this all in place. Also, it turns out the clear acrylic looks really awesome, unless you suck at hot glue, and everybody can see how bad you are at it. So, also, hot glue is freaking hard. Has anybody tried to hot glue something recently? That junk is terrible. But anyway, that's what you do. So a little bit of that. You can see I've got everything wired in there. And then in order to solder this all together, in order to get it to work, you actually need to solder these diodes into place. And what you're really doing is you're just creating a grid. You're creating rows and columns. And then that allows you to sort of multiplex all this stuff into an Arduino and then actually create signals off of it. So you need these diodes. And I don't have a circuit board, so I just soldered them pin to pin. So you can see what I've done here is I've soldered to that leg of the switch and then into the front end of the other diode. And I just do that a lot. So yeah, then you create these rows this way. And this is actually pretty straightforward. I think this was the work of a couple hours or so to do the whole thing. And then you need to strip all this wire, which is the worst part of the entire experience, besides hot glue. So what you need to do is you need to strip this wire out so you can actually create columns out of it. And then once you do that, you can solder that in there. And I don't know if you can tell here, but there's a problem. Right there. That's bad. That's considered a short, I think is the technical term for that. And you have to be careful for that kind of stuff, so you just check it all with a multimeter as you go. So then, yeah, once you get all that stuff in there, then you can wire it to this Teensy, this Arduino thing. And the nice thing about the Teensy is it behaves as a HID out of the box. So you don't have to do anything special. You can just kind of wire it all in there and solder it all up. And then you just drop it in there, just like that. Super nice and clean. It's easy. And you can see I'm actually using some of the wire to hold it in place because, that makes sense. Strip more of that out and then plug it in and you'll see you get this red light and it all works great the first time you plug it in and you don't have to worry about it. You don't have to resolder any of it or take it back apart. And the nice thing is there's tons of great keyboard firmwares out there. You can just install it on this thing and actually just map it to all these switches. So, switch 1 would correlate to 1 or A or whatever you wanted it to be. And you can see, I don't actually have enough keys to be a real keyboard. This is a 40% keyboard. And so I use a lot of modifier keys to jump layers and create new macros and all kinds of fancy stuff. And then once you get it all together, you put the keycaps on there, and it looks something like that. And there's my Instagram photo because, filters. And yeah, and there it is with a keyboard for scale. I don't have a shoe, so no shoes for scale. If you're into mechanical keyboard subreddit. Apparently no one but me is. But yeah, that's what it looks like. It's what I used for a while up until I built 3 more keyboards. And now I'm using one that's a little bit bigger called an ErgoDox. But anyway, my whole point of all this is that it's not that hard. And it's actually really fun and really rewarding to get to do something and build something with your hands that you can actually use all the time. And turns out we all type a lot, I think. So you should kind of care for all that stuff. Anyway, that's it for me. I'm done, so thank you.
Thank you, everybody, for coming. Come back to us next week. Blardo, who was supposed to talk today, and I am now publicly shaming Blardo, yes, if you're watching. He is actually going to be making up for his great transgression today and coming at us next week with a talk on OAuth 2. So come out for that. Should be good. He's going to be digging deep, and he's going to lay the knowledge on you. See you guys next week.